Good evening and welcome to the open evening talk on BTEC Applied Science. So first of all, what is applied science? Applied science is a course that consists of all three sciences. You'll be studying a few little topics from biology, chemistry and physics. The course is designed to ensure progression into higher education, employment or apprenticeships. It is broken down into 4 units that will be completed over the 2 years. In the first year, you will complete 2 units, and the second year, you will complete the remaining 2. If all 4 units are completed, this is the equivalent to 1 A-level. So first of all, we'll look at what is in the Year 12 content. Year 12 is consisting of Units 1 and 2. Unit 1 is consists of an exam with a little bit of content, and Unit 2 is the coursework aspect of the course. With Unit 1, this is a principle and application of science. With this unit is you complete a biology, a chemistry, and a physics part of the course. So if we look at the chemistry to start with, this will look at the periodic table, the properties of elements. You'll start to look at little things to do with like shell structure and things like that, how we can group elements together in a periodic table. With biology, you look at the structure and functions of cells in a lot more detail. You start to look at other parts of the cell like the Golgi, the smooth endoplasmic reticulum and the rough endoplasmic reticulum and their functions within a cell. And we start to look at tissues in a lot more detail. So the main tissues are nerves and how they send impulses and cross between synapses, and also how the muscles are able to contract. Physics, you look at waves in a lot more detail and how they're used in communication, things like radio waves and satellites. Most of Year 12 will consist of the practical part of the course. This unit includes quantitative laboratory techniques that will be used in university or maybe in apprenticeships after the course. So what Unit 2 consists of is 3 different practicals. Now, there are multiple practicals involved with this, but the first practical involves titrations and colorimetry to determine unknown concentrations of solutions. The second lot of practicals is looking at calorimetry, and you'll be drawing cooling curves to look at when they change from a solid, a liquid, and a gas. And you do 3 different chromatography experiments to identify components in plants and amino acids. With this part of the course is you will do all of the practicals and you will have to do a practical write-up afterwards. Now, the practical write-ups, the teachers will give you a success criteria of exactly what is needed to achieve each of the grades. You'll be given an opportunity to improve these grades, and your teachers will probably give you a good indication as to what grade you're currently working at. Unit 3 is covered in Year 13. This, again, involves a lot of a practical aspect of the course, but this time is a lot more involved with planning experiments. So areas that are covered with this is planning scientific investigations, collecting data, processing this data and interpreting it. It's drawing conclusions and evaluations from the graphs that you've drawn. And the units that are covered are enzymes in biology, it is electricity in physics, and in chemistry, it looks at the amount of energy in different alcohols and foods. Also, you look at diffusion of molecules, and there's a big emphasis on plants and their environment. So you'll go into fields nearby to the school. You'll look at like a lot of field work to do with like quadrats, how human activity impacts on things, and also you'll look at photosynthesis and what affects the rate of photosynthesis. So if we just look at the assessments, it's assessed in three different ways. The first part is an assignment that is marked internally. This can be called up from the examiners afterwards, so any coursework is marked internally, but Pearson do come and check these afterwards. Also, there is a task that is set and marked by Pearson, and it's completed under exam conditions. Okay, this is usually involved with Unit 3, where Pearson will actually give the schools one of the experiments that we talked about. The students will have to complete that experiment. They'll have to plan it all out. They'll have to write their own results table, draw their own graphs, and there'll be a few questions based on this. The other part is a written exam. This is in the first year of the course, and it is 90 marks. It requires 30 marks to pass that part of the course. So last of all, we have the minimum entry requirements. To study applied science at Elaine's, it is required to have 5 GCSEs, grade 9 to 4. It is essential that students have a 9 to 4 in both maths and English. There is a lot of statistics involved, especially in year 13. You have to calculate moles in year 12. It is therefore essential that students get at least a grade 4 in maths. And English is really important because of all the coursework and the practical write-ups for these. So English is also essential. Also, it'll be required that students have a 4-4 in science. Thank you very much for listening to that. If you have any other questions about applied science, please do not hesitate to contact myself at e.taylor@elaines.staffs.sch.uk. Thank you very much for listening.